Hello, quick video on trig ratios in GCSE. Sometimes people will talk about it as just a SOHCAHTOA. So what do we use this for? Well, we use it to find missing out sides or angles in right angled triangles. Like an example here on the left, we know that this side is 10 centimeters. We know that angle is 30 degrees. Can we find the length of this side? The opposite side? Yes, we can. We've got three ratios: sine, cosine, and tangent, and these ratios are defined by the ratio of the lengths of the sides, and they're often seen as well over here on this side, presented as triangles, each one reading SOHCAHTOA and TOA. So what do we need in order to use trig ratios? Well, we need a pair of values, we need an angle and a side length, or we need two side lengths. Okay, let's have a quick look down at some of the important assumptions here. First one, we have a convention for naming the sides and angles of a right angle triangle. Well, we've known for quite a while that the long side's called the hypotenuse, but we need to name the other two sides relative to the angle. So here's our angle. So this side is on the opposite side to the angle, and that's called the opposite. And this one is adjacent or next to the angle, so that's called the adjacent. This all works because similar triangles have the same ratio of the lengths for the same angle. So if I were looking at a small triangle here, this opposite side divided by that adjacent side would be the same ratio. We could just scale it up if we wanted to get this larger triangle with its opposite side over its adjacent, and we can do exactly the same thing with a hypotenuse, the long side. So we could do the ratio of the opposite to the hypotenuse. For the small triangle, one divided by the other will be the same as the opposite to the hypotenuse of the smaller triangle. So all of that works. They're defined as the ratios of the sides. So for this sine of this angle here, x is the length of the opposite divided by the hypotenuse. Cos is the adjacent divided by the hypotenuse, and the tan is the opposite divided by the adjacent. So we can see these in these triangles. If we were to look at this first triangle, it's works like the DST triangle. So the sine, if we want to know what the sine was, it would be the opposite divided by the hypotenuse. If we wanted to know what the hypotenuse would be, it would be the opposite divided by the sine. And if we wanted to know what the opposite would be, it would be the sine times the hypotenuse. And this works all the way around these triangles, just like DS and T. So that's what's going on, and that's why we can use it. So let's do some examples now. Okay, let's go back to one we looked at first. So we know this side is 10 centimeters. Well, that's a hypotenuse side, isn't it? It's the longest side. There's our angle, and what we're trying to find, we're trying to find our opposite side. So we now look at our three triangles here, our little trig triangles, and we decide which one to use. Well, we want to find the opposite, and we know the hypotenuse, plus we know the angle, so we know what the sine is. So we know 2 out of 3 on that sine one, so we could use it. Looking at the others, well, we don't know what the adjacent is. We do know what the it's not going to help us, is it, because we're trying to find the opposite, so it's not in this triangle, so that's of no use. And on this final triangle, yeah, well, it's got the opposite in, but it's got the adjacent in. We don't know what that is, even though we know the tangent. So we only know 1 out of 3, so that's no use. So as using this analysis, we always find that there's only one triangle we could use. In its fundamental form, sine is opposite over hypotenuse, but after what we looked at earlier about using it in different ways, if we wanted to find our opposite, we can multiply our sine by our hypotenuse. So there's our opposite, is the sine divided by our hypotenuse. I'm just going to leave the O for short for opposite. Once we know that the angle is 30 degrees over here, don't we? And we know that the length of the hypotenuse is 10. So there's our sine 30 times 10. Sine of 30 is 0.5. And times by 10, therefore the opposite is 5 centimeters. Let's follow through and do an example where we need to find an angle. Okay, so let's have a look at this one here. Here we know two sides, that's our hypotenuse, and we know this side, well, that's our adjacent, because adjacent to the angle, and we want to find the angle, don't we? So we need to find a triangle where we've got the A and the H in. We know both of those. Well, the A and the H aren't in the first one. The A and the H are in this one. There's the A and the H, and they're not in that one. So here we know the A and the H, so we can find cosine, can't we? So cosine equals adjacent over hypotenuse. Well, we know the adjacent side was 7. We know the hypotenuse is 10. So dividing one by the other, we know that the cosine of x must equal 0.7. Now, in the old days, we'd have got to this point, we'd have gone and found some tables, and we'd have looked up 0.7, and it had told us what the angle is. But in these days with calculators, we can just do our inverse cos, or our cos minus 1 of the value we've just calculated, and our calculator will tell us that that's 46 degrees. So here we go. Here's our summary. We've got 3 different ratios: sine, cosine, and tangent. We've got our basic definitions here of opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And we've got our 3 triangles that we can use. And all triangles going on the sides, it's a divide. Going on the bottom, it's a multiply. So we can see what we're doing. And to use it, to pick the triangle, we need to look for the triangle where we've got 2 knowns and our unknown. And if we do that, hey presto, we can find our missing side or angle. I hope that's of use.